solving, I didn't realize that I didn't change these instructions down here. I want everything in radians. We're not doing anything in degrees anymore. Everything's in radians.
Like every 2
For the most part, because, and the main reason for that is because in most upper level math classes we don't use degrees anymore. We use radians. So it's just easier. And if y'all the more you use it, the more familiar you get with it, and then it doesn't bother you anymore. Okay, so we're finding all of the solutions, which in algebra always means you get the variable by itself. The variable is usually x, but whenever we get into trig, we start using theta instead of x. So what we're trying to do is find all the solutions or get theta by itself. So right now, theta has a cosine with it. So how do I get rid of cosine?
Tan cosine, or
Inverse cosine, or what we call arc cosine. So I'm going to inverse cosine this. And so now I have theta equals the inverse cosine of negative square root of 3 over 2. So I have to figure out first of all, where is cosine square root of 3 over 2? So again, if you know your left-hand trick, now if you have your unit circle memorized, you can just maybe think about it real quick. But I use my left-hand trick. So cosine is the x value. That means I'm going to be looking at my top fingers. And the number on top of this fraction is a 3. So that means I need 3 fingers on top of my hand. So 1, 2, 3.
4.
So I'm going to fold that one in, which means I have just folded in my pi 6 finger.
Or you go opposite because it's inverse?
But pi over 6 would be positive because everything's positive in quadrant 1, and this is negative. So I need to know where cosine is negative. What quadrant is cosine negative in?
2.
2 and 4, but let's go with 2 first. So I need the pi over 6 that's in quadrant 2. What pi over 6 is in quadrant 2?
Wait, 2 and 4.
It should be
2
4 pi over 6.
and 3, I'm sorry. It's what?
4 pi over 6.
Close.
5 pi over 6.
5 pi over 6. And then we learned yesterday, actually we learned a while back, that you can get that initial angle, and the rule for cosine, which is in this little chart that's in your solving for all notes, for the general solution of cosine, the rule is I get a value, s, and I can make it both positive and negative, and then add 2 pi in. So I got one answer, 5 pi over 6. I can make it both positive and negative, and add 2 pi in.
Dang.
Because remember, there are infinite solutions. And that's what that n does for me, is it would let me get, and tomorrow we will start getting more solutions.
So what is that?
N is a number that you're going to plug in, like I would plug in a 1. And then that would give me 2 solutions, that would be 1 trick around the unit circle. If I plug in a 2, I'm going to go 2 tricks around the unit circle, so I have 4 solutions. If I plug in a 3, I get 3 tricks around.
When you did the left-hand trick, you were going 6, 4, 3 the opposite way. Are you doing that?
No, I went 6, 4, 3. So that was my pi 6 finger.
Why are you taking that finger down?
Because it's negative.
Because I needed a square root of 3 on top. See, we're working backwards. I'm going to do another one. We're working backwards.
Is that because it's the inverse of cos, or is that
Yes, because I don't know the angle.
It's not because it's a
I know
negative.
the. It's because I know the ordered pair instead of the angle. So, okay, so my goal here is to get theta by itself. And right now, there's a -1 and a sign. What am I going to do first in order to get theta by itself?
Subtract or add 1.
Yeah, add 1 to both sides. So I'm going to move that +1. Now, when I move it to the other side, I'm going to need a common denominator in order to add it to what's already over there. So is everybody okay if I just go ahead and write it as 2 over 2?
Yeah.
All right, making sure. So that gives me sine theta equals, if I'm going to add straight across the top, so my denominator is 2, I have -2 plus 2. What happens to those?
They cancel.
Those cancel, and I'm left with just negative square root 2. All right, so now I have sine theta, and I need theta by itself.
Inverse sine.
So inverse sine. So I get theta equals inverse sine of negative square root 2 over 2. Which means I don't know the angle, I'm looking for the angle. What I know is the y value of a ordered pair. So if I know the y value, that means bottom fingers, right? Because that's y, my bottom fingers. And I need 2 of them down there. So if I put 2 fingers on the bottom, I would fold in this finger to separate my ordered pair. See, that's my top, that's my x, and that's my y, right? So this is my y value. So I folded in which finger?
Your pi 4 finger.
My pi 4 finger. So that means, but it's not, it can't be pi 4 because I did fold in my pi 4 finger. That's my reference angle. But I actually can't use pi over 4 because sine is negative here, and sine isn't negative in quadrant 1. Sine isn't negative in quadrant 2. Sine is negative in quadrant 3. So what's the pi over 4 in quadrant 3?
Yeah, 5.
5 pi over 4. And then I'm going to go to my little chart. Soon enough, you'll have a little chart memorized to see with sine, how do I generalize my solution? So you first find your solution, which I did that. And then I can add 2 pi n, so plus 2 pi n. But I also have to do this next piece. I have to do pi minus my solution. So pi minus my solution.
Would be 1/4 pi.
That would be pi minus 5 pi over 4 plus 2 pi n. And let's just simplify that real quick. If I'm going to get a common denominator here, I'm going to write this as 4 pi over 4. Which means it is negative pi over 4 plus 2 pi n.
You have to do both of them, or?
You have to do both of them. And the reason that we have to do both of them, so there are 2 solutions. Right here, there's 2 solutions. Remember, with cosine, there's a positive and a negative.
Yes.
So there's 2 solutions there.
Okay, so that's a
There's
solution.
2 solutions here.
That's a solution, and that's a solution.
And the reason why is because there is a going into the water solution and a coming out of the water solution.
So tangent only has 1 solution?
Tangent only has 1. So when we go into the water and come out, that gives me my 2 solutions, and then the plus 2 pi n would give me the next 2 solutions, and the next 2
So if
solutions.
we were to put pi in the calculator, everything would be a solution?
So, could it, 7/4 pi plus 2 pi n be an answer too? That's the same
Yes.
thing as pi, negative pi.
Yeah, yes. Yes, and so if you do that, like if you get the sign that's in quadrant 3 and quadrant 4 and add 2 pi n, you can do that too.
Okay.
'Cause it works that way. Okay, number 3, I need to get theta by itself, so what do I do first?
Okay, first,
You
what you're going to
subtract
do
2.
is you're going to subtract the 2.
Okay.
So it'd be
subtract
-2.
Thanks, Jude.
Alright, so I've got 2 tan theta equals -2. Now what?
Then you
Divide by
or
2.
Divide by 2, okay. So now I have tangent of theta equals -1.
Then you do inverse tangent.
Inverse tan, okay. Alright, so tangent is a little bit more difficult because you can't necessarily left hand trick it. Except, I told y'all this yesterday and I'll say it again, it really will be easier for you if you just memorize the tangent of quadrant 1. If you just memorize tangent of pi over 6, pi over 4, and pi over 3. It really is easier that way. But if you don't, it's fine. Because you can just keep switch flip them all and figure it out. But 1 is the easiest one. And you should just know this one because you should. But if you remember that tangent is y over x, and my ordered pairs are fractions, the only way for a fraction to equal 1, what has to be true? Oh, so that is true of sine and cosine. Tangent on the axis is always going to be 0 or undefined. But in order for tangent to be 1, it has to be a number over itself. That's the only way you get a 1 when you're dealing with fractions, is if you have a number over itself. So if I'm left-hand tricking it, the only way I get a number over itself is right here. Because I got a 2 over it too. So tangent is 1 at the pi 4s. But I need -1, so what quadrant should I use?
Second one. Students.
Quadrant 2. So what's the pi over 4 in quadrant 2?
3 pi.
All right, so 3 pi over 4. And if I look at my rule on my page for tangent, the rule for tangent is you get a solution
Add pi in.
and you add pi in. And that's it, because tangent doesn't have a pair. It doesn't go back in the water. Remember, it just comes out. So, and because its period is pi, not 2 pi, that's why it's pi in. All right,
What paper is that?
that is solving for all, the page I gave you yesterday.
It's the one that this one written here.
All right, so is everybody sort of kind of a little bit okay?
Yes.
Go.
Maybe.
If you're not, and you weren't here yesterday, you might want to watch the video for solving for all.
I found someone else's